Hello, everyone, and welcome. Thank you for making time to be with us today. My name is Shadrach Anyuo, and I'm a Senior Solutions Architect with AWS. In this session, we are going to share with you a prescriptive guidance on how to protect your AWS application against threats. We will also share with you how to architect your applications efficiently by taking advantage of our DDoS services for threat mitigation. We will go further to provide a playbook on how to automate application defense using AWS services. And lastly, we will share with you our final thoughts and reference materials that you can use as you continue to build on AWS. I would like to mention that this is a level 300 presentation, and I assume that you already have a working knowledge of AWS services. Let me start by providing a background information on some of the common application threats we see today, as this will help us to build a common understanding as we move deeper into the presentation. Application threats can be grouped into three major categories. We have DDoS attack, application attack, and bad bots. DDoS attack occur at application and infrastructure layers and are usually the common types. They are always large in volume, and the intention is to overwhelm your network capacity or tie up your application resources. Since they are easy to identify, to effectively mitigate them, you must have an architecture that scales up capacity more rapidly than the inbound traffic flood to absorb the extra attack traffic. And that will allow your application to respond to your legitimate users. Application attack, on the other hand, tend to be more sophisticated and typically take advantage of application vulnerabilities such as failure to run software updates or patches. Due to the constant change in the attack vector, mitigating against application layer attack requires a deliberate approach. Then we also have bad bots, such as content scrappers that automate attempts to access your web applications with an intention to steal content or record competitive information, such as pricing. These threats not only cause service disruption, but can also result in financial loss and even reputation hit. Then, how can we at AWS enable you to mitigate these application threats? At AWS, security is our top priority, and our DDoS mitigation capabilities are automatically provided through a fully cloud native approach. With AWS, you can build architectures that operate at scale to absorb and mitigate attacks as they happen. We also provide services that you can use to build defense against sophisticated application attacks through event driven automation processes. These capabilities come with no upfront cost, as you only pay for what you use. Now, before I go into discussing specific services, let me start by highlighting some of our security services that our customers are using today. These services are divided into five main pillars. The first pillar is the identity pillar. Here we have services that enable our customers to identify and approve users who interact with AWS services through API calls. If you have ever logged into AWS console, then you've used AWS IAM service. The next one is a detective control pillar. And here we record events and behaviors occurring inside your AWS environment. And we have services such as CloudTrail, Amazon CloudWatch, or even Amazon Guard Duty. Under infrastructure security pillar, we have services that helps you to block access based on predefined rules on malicious behaviors. And here we have two specific services that we are going to discuss deeper and into more details. That is AWS WAF and AWS Shield. Then under data protection pillar, we have services that helps you to analyze data access patterns and also to protect your data either at rest or in transit. Lastly, we have incident response pillar, and here we have suites of services that helps you to automate security response, and those services are such as Lambda and even AWS config rules. Now, let me deep dive into specific services that you can use as you build mitigation layers in AWS. And the first service that we're going to look at is AWS Shield. AWS Shield is a managed DDoS protection service that safeguards applications running on AWS. It provides an always-on detection and automatic inline mitigation that minimizes application downtime and latency. AWS Shield comes in two tiers. We have AWS Shield Standard and AWS Shield Advanced. AWS Shield Standard tier is available to all our customers at no additional charge and defends against 96% of today's most common and frequent Layer 3 and Layer 4 DDoS attacks. AWS Shield Standard, on the other hand, is not enabled by default. It's a paid-for service that costs $3,000 per month, but offers you a more tailored detection based on your application traffic patterns. It also uses your application health to improve responsiveness and accuracy in attack detection and mitigation. AWS Shield Advanced also gives you a complete visibility into DDoS attack with near real-time notification via Amazon CloudWatch. It also comes with a DDoS cost protection to safeguard you against scaling charges that might result from DDoS-related usages spikes on protected AWS services. It also offers you a proactive engagement from DDoS response team when a DDoS event is detected. This is an example of AWS Shield global threat environment. It provides an overview of the threat landscape at a specific time. And as you can see on the dashboard, the most common attack vector is SYNFlood at the time of the report. Probably this has changed now as this data is actually captured in real time. This is another view of the same report on an hourly basis. I would like to move to the second service, which is AWS Web Application Firewall. Web Application Firewall works at Layer 7. It enables you to create security rules that block common attack patterns such as SQL injection, cross-site scripting, and even bad bots. AWS WAF gives you control on how traffic reaches your application by allowing you to define rules that filter out specific traffic patterns and block unwanted traffic. It also provides real-time metrics that captures raw requests that include details about IP addresses, geolocation, URI, user agent, and referrers. For quick setup, AWS WAF comes with predefined managed rules, which are regularly updated as new issues emerge. You can also seamlessly integrate with third-party security vendor rules, which you can subscribe to from AWS Marketplace. It offers you a flexible rule language that allows you to build your own customized rules based on the kind of mitigations measures you want to take. And AWS WAF also includes a full-featured API that you can use to automate creation, deployment, and maintenance of security rules, thereby allowing you to be able to respond faster to security threats in near real time. And we'll be able to demonstrate to you how you can be able to use this API capability to be able to build automation against application threats. With WAF, you pay for what you use. There's no upfront cost or commitment, and the pricing is based on the number of rules deployed and the web requests are received by your application. AWS WAF can be deployed on three AWS services. We have Amazon CloudFront as part of your content delivery network solution. You can also deploy it on application load balancer that fronts your web servers or origin servers running on Amazon EC2 or on Amazon API Gateway. Configuring WAF rules can be a daunting task in large and complex organizations. We therefore have a WAF Firewall Manager, which allows you to centralize configuration and management of firewall rules across accounts and applications. It makes it easy for you to deploy new applications and resources into compliance by enforcing a common set of security rules. With AWS Shield Advanced, AWS WAF Firewall Manager comes at no additional cost. But to use AWS Firewall Manager, you need to have AWS organization deployed and AWS config enabled for your accounts. We have spent time looking at key services that our customers are using today to mitigate application attacks. That is WAF. We've talked about Shield, both standard and advanced. I've also shown you how to manage WAF rules deployment in large setups using Firewall Manager. I therefore want to transition into automation response patterns and share with you two approaches on how you can integrate Web Application Firewall together with other AWS services to build a more robust and automated defense against application exploits. The first response pattern that we are going to look at is building a resilient architecture. This is where you start by isolating your resources by the use of a VPC. And a VPC is a secure, simple, and customizable network construct that allows you to logically isolate your services in AWS. It allows you to partition your AWS network into public and private subnets. And within a VPC, you can implement multiple layers of security through the use of security groups at an elastic network interface layer and network access control list at the subnet layer. With this architecture, you also deploy application load balancer that functions at layer 7 and offers a single point of contact for clients as it distributes incoming application traffic across multiple targets controlled by an autoscaling group. This architecture helps you to mitigate both infrastructure and application layer attacks as it allows you to operate at scale and also reduces the attack surface area as it limits the opportunity for bad actors to target and access your applications directly. As is, this architecture represents two issues. One, the mitigation is happening inside your VPC, closer to your applications. And two, scaling comes with extra cost unless you have AWS Shield Advance. In order to build more resiliency, we recommend pushing mitigation closer to the attack source and away from your VPC. And this is where WAF comes into play to be able to provide you with a customizable rules to block or rate limit malicious requests. You also deploy Route 53 to mitigate complex attacks by allowing only the most reliable DNS queries. You also deploy Amazon CloudFront, which works with AWS Shield to mitigate layer 3 and layer 4 attacks, and also allows you to cache static content and serve them from AWS edge locations. This in turn helps you to reduce the load on your origin servers. We also have API Gateway, which acts as the entry point to your application, thereby making it harder to detect your application components. The value that these services do bring is that these services are global, they automatically scale, and are also fault tolerant. The second approach that I'm going to look at involves using WAF for security automation. And in order to do that, let me first of all take a step back and highlight three key vital steps that you need to undertake as you consider building automation using WAF. The end game of automation is to quickly remediate by taking actions based on predefined triggers or changes detected in your environment. These actions may include dynamically changing WAF rules, such as allowing IP or blocking IPs, sending notifications to response team, or even sending signals to third-party tools. But before you take actions, you need to keep track of every changes in your environment, such as abnormal traffic increase from a particular source, large number of packet errors, or port scanning, among others. This allows you to be able to detect and identify unusual behavior based on the rules, triggers, or thresholds that you've set up within your event sources. But detection cannot be achieved when we are not able to log and track events as they happen either in real time or after a certain period of time. Logging helps in capturing events as they happen in the form of logs, such as VPC flow logs, DNS logs, WAF logs, application load balancer access logs, or even content delivery network logs. We also have services that you can use at every step of logging, detection, and remediation. And I would like to highlight those services in the next slide. The first service to look at is Amazon Simple Storage Service. As you are aware, S3 is an object storage service that enables customers to store and protect any amount of data for a wide range of use cases. We also have Amazon CloudWatch, which is a performance monitoring service, and it has two key services for automation. That is CloudWatch events, which becomes aware of your operational changes as they occur. And this enables you to create simple rules that match events and route them to one or more target functions or streams for actioning. CloudWatch events delivers a near real-time stream of system events that describe changes in your AWS resources. We also have CloudWatch alarms, and these are exceptions raised based on metric thresholds you've set as a user and are very helpful in performing monitoring. We also have AWS Lambda, which lets you to run a code without provisioning on managing servers and can also execute code in response to triggers such as changes in data, shifts in system states, or actions taken by users. Now, in the next slides, I'm going to share with you 4 specific use cases where you can use WAF to automate application layer defense. Then after, I will also share with you an overall architecture that combines all the 4 scenarios together with other measures to be able to address Open Web Application Project Top 10 security risks. The first scenario that we are going to look at is IP reputation lists. A number of organizations maintain reputation lists of IP addresses operated by known attackers such as spammers, malware distributors, and even bad bots. This solution leverages the information in this reputation list to help you block requests from malicious IP addresses. In this scenario, an event is scheduled using CloudWatch event rule to run a Lambda function. The Lambda function gathers and passes data from third-party sources and updates AWS WAF block list with the most current IP addresses. This is an example of an event rule configuration where you specify the schedule, the Lambda function, and the input sources. And in this case, this is coming from third-party sources. And this is also an example of a sample of codes that you run in the Lambda function to update IP set list on the WAF service. The next use case is automated mitigation against scanners and probes. Malicious sources can scan and probe internet-facing applications for vulnerabilities. They do this by sending a series of requests that generate HTTP error codes, and you can use this history to help you identify and block malicious source IP addresses. This solution creates an AWS Lambda function or Amazon Athena query. Amazon Athena query is a serverless interactive query service that makes it easy to analyze data in Amazon S3 using standard SQL language. Here, the Lambda function automatically passes log files that comes from either application load balancer or CloudFront, and then counts the number of bad requests from unique IP addresses and updates WAF IP list to block further scans from those addresses with high error rates. This is an example of a threshold configuration file that you can be able to use to define your configuration settings. The next scenario that I'm going to look at is mitigating against HTTP flood. This solution automatically triggers a rate-based rule when web requests from clients exceed a configurable threshold. Here we also use another configuration file to be able to define the threshold. And in this case, the WAF logs are actually ingested using Amazon Kinesis Firehose, which is a service used for capturing and loading streams of data to data stores such as S3. The WAF logs are ingested into S3, and based on put events, this then triggers a Lambda function that analyzes the log files to identify IP addresses that are sending more requests than the defined threshold. The Lambda function then updates the WAF IP set condition to block the identified IP addresses. This is an example of a WAF log file ingested into S3 via Amazon Kinesis Firehose. The last use case is managing bad bots. When you operate publicly accessible web applications, you have to trust that the clients accessing your content identify themselves accurately and that they'll be able to use the service for the purposes intended. However, some automated clients, such as content scrappers or bad bots, misrepresent themselves to bypass the restrictions that you put in place. This solution helps you to identify and block such clients and scrappers by the use of honeypot concept. Honeypot is a security mechanism that allows you to be able to detect, deflect, or in some manner counteract attempts at an attacker. Generally, honeypot consists of data, for example, in a network site that appears to be a legitimate part of the site that seems to contain information or a resource of value to an attacker, but actually is isolated and being monitored. In this case, where a bad bot accesses the honeypot endpoint, it triggers a Lambda function which intercepts and inspects the requested header to be able to extract IP address of the source that accessed the endpoint. We've implemented honeypot endpoint using an API gateway, and this is an example of a Lambda function that picks the source IP of the bad bot, and then the Lambda function updates the AWS WAF IP set condition to block that IP address that has been identified. We have looked at 4 ways by which you can use WAF to automate application threat mitigations. All the above use cases can be combined into a single overall architecture. And at the core of this architecture is AWS WAF Access Control Lists. AWS WAF Access Control List acts as the central inspection and decision point for all incoming requests to the web application. With WAF API, you can automatically update rules, as I have demonstrated, to build a more robust and near real-time mitigation response. This overall architecture includes AWS managed rules as part of the deployment, and this solution is available in the form of a cloud formation template and is ready for deployment. We also recommend that customers configure a custom baseline monitoring system for each critical endpoint deployed in their environment. You can achieve this by using Amazon CloudWatch to monitor your applications that run on AWS. This is an example of CloudWatch dashboard that shows custom baseline monitoring system and displays key metrics such as allowed versus blocked requests. And these metrics can be used to track known threats when blocked requests increase, or a new version of an attack when the requests are allowed to access the system. We also have bytes downloaded versus bytes uploaded, and this metric helps you to identify when an attack targets a service that normally does not receive large amount of access. We also have ELB spillover and queue length, which also is an important metric that can help you to verify if an attack is causing damages to your infrastructure, and if the attacker is bypassing uh, Amazon CloudFront or even AWS WAF layer and is attacking directly your unprotected resources. We also have ELB request count that helps you to identify the damages to your infrastructure. And we've also used these particular metrics to be able to demonstrate how you can mitigate against HTTP floods. We also have CPU utilization, and these metrics you can also use to be able to identify the damages that an attacker is causing to your resources. All the metrics can be configured to send alarms through simple notification service and even a third-party tool. Now we've come to the end of the presentation. I've demonstrated to you how you can be able to mitigate application threats. I've shown you our services such as AWS Shield, both standard and advanced for DDoS protection. I've also talked about AWS WAF, and I've also demonstrated to you how you can be able to use AWS WAF to automate application threat mitigation. Threats are always there, and bad actors will always be there. The most important thing is, how are you prepared to deal with such threats? As you design your architectures, always design with bad actors in mind. A plan for scale to be able to absorb and mitigate layer 3 and layer 4 attack while reducing the scope of the impact, and always enhance application security through event-driven automation. Here is a link you can use for different purposes. Once again, thank you and happy building on AWS.